All right, welcome back, guys. So in this video here, we're gonna talk about briefly introduce polynomials and how we're gonna add and subtract polynomials. So before this lesson, we introduce algebraic expressions. So those are those are just terms like 5x squared plus 1, right? So you have these terms that add or subtract each other's, or you can have x squared y squared plus 5x squared, or something like that. Usually a variable coefficient or just a constant. So let's say 3 is considered as algebraic expression. So now, what we can do is we can introduce the algebraic expression has a single term. So we say that if an algebraic expression has a single term, we call it monomial. Okay, and then now we can define polynomial. So we say definition. We say a polynomial is a monomial or a sum of just a sum of monomials, right? So an example would be, let's say, just like these algebraic expressions, but we can just now combine them. So we can say, all right, well, we have 5x squared plus 3x plus 1, so that is a polynomial. Or we can have 1/2 x to the third plus 2x squared plus 5x plus 7, so that's another polynomial. So it turns out that we have three basic type of polynomial. We have the monomial already, so we said monomial, just a single term. Monomial is one term polynomial. And then we have binomial. So binomial would be two terms polynomial. And then we have the third one will be trinomial. So that's the three terms polynomial, right? Some other basic stuff regarding polynomial. Let's say we have examples such as, let's use 7x to the third plus 2x squared plus x plus 10. We say that this is the coefficient. So the 7 is the leading coefficient. We say that's leading coefficient. And then this is the degree. So we say that's a degree. Right. So in this case, the degree of this polynomial is 3, which is the highest degree in this case. All right. What we can do with polynomial is we can add and subtract them. So that's using just combining like terms that we learned from the previous class. So let's say if I want to add and subtract polynomial. So let's say we have this example here. So we have this polynomial add to this polynomial. So the way we add and subtract these is just combining like terms, and that's just based on the variable and also based on the degree as well. So this term and that term can be combined because both had a variable x and both had degree 3. So what we can say is, okay, well, negative 5 x to the third plus 3x to the third, that becomes negative 2x to the third, right? Negative 2x to the third. Okay. And then next we have 6x squared, but there's no x squared term, so we're just gonna leave it as how it is. There's no other terms to combine it. The next term is we have 2x, so that combined with 4x, so that's 6x, right? And then after that we have minus 7, and then plus 1. Well, minus 7 plus 1, so that's become negative 6, right? So that's the sum of these two polynomials. We can also subtract them as well. With subtraction, a little bit more tricky because when you subtract a polynomial, you literally subtracting a quantity. So in this case here, what we need to do is we need to rewrite this problem as the negative sign distributed to these terms, so that way when we add them, we don't make mistakes with the sign. Okay, so negative 2x squared plus 5xy minus 7y squared. All right, so we have 3x squared, and then we have negative x squared. Notice that the 7y squared cannot be combined with this x squared term because the variables are different. So that just gives us negative 5x squared. Next, we have 4xy and then 5xy, so that will give us 9xy. All right, 9xy, and then that's just minus 7y. That's how it is. Okay. Okay, we can also add and subtract polynomials with much more complicated coefficients. So it's easier when we add and subtract these terms where the coefficient are whole numbers, and they're easy to just add and subtract. But when the coefficients are a mix of whole numbers and fractions and positive and negative, it can get a little more messy to add and subtract polynomials. So same thing here. What we want to do is we want to distribute the negative sign to these terms before we add and subtract any of those. So what I'm going to do here is I'm going to distribute the negative sign and then group these terms as like terms right next to each other. So I have negative 9x to the third next to the x to the third. And then I have 2/5 x squared there. And the next term I'm going to have is a negative 1/4 x squared. And then next we have 3/8x, and then that become plus x. And then we have a negative 1, and then minus, so negative 1 minus 5/6. So now we can start combining these terms. All right, we need common denominators because we have a 4x to the third and then negative 9x to the third, so we need common denominators. So I can turn this to 8/2. All right, 4 is 8/2. And then over here I need a common denominator of 20, so that I can turn this 8/20 x squared minus 5/20 x squared. So the LCD in this case is going to be 20, so I times by 4, by 5, by 5, right? And then next I have 3/8 and then 1 there, so I can turn that 1 into 8/8x, and then this becomes 6/6 minus 5/6. So I can now add these like terms. Right, negative 1/2 x to the third minus 13/20 x squared plus 11/8x minus 11/6, and that should be our answer there. Okay. I'll leave this part for you to try on your own. Okay. The next thing what we're going to do is we're going to multiply these polynomials. So I have several examples for us to look at. And right, so these examples are just based on the type polynomials being multiplied. So the first example we're looking at, monomial times monomial, and then here we have a monomial times a binomial. So if you have a single term times single term, all we're doing is multiply the coefficients, and then we multiply the variable, and then when we have x times x squared, that becomes x to the third, y to the fifth. So we're just applying the properties of an exponent to add those exponent there. Over here, we want to use a distributive property, so that becomes 3n minus 12, right? Here's some more with monomial times a trinomial in this case, okay? So we have a monomial times a trinomial, so we do this here. We distribute the terms, so that gives us 2x to the fourth plus 6x plus 10x squared, right? All right. We can do the same thing in fraction as well, right? So we can distribute this term to the trinomial and multiply these coefficients. So we have 1/2 times 4/3. So 1/2 times 4/3, that's become 4/6, and 4/6 reduced into 2/3, and then a y and a y, that become y squared, and then z to the 5th, plus you have 1/2 times 8, that's 4, and then y times y is y squared, and then z squared leave. And then we have 1/2 times 1/6, which is 5/12, and then the yz squared. Okay. This next example here is more on binomial, variation binomial. So we have a binomial times binomial. We have a binomial times itself, and then we have the binomial times itself with the opposite sign. And we have fraction, and then we have some weird one here. Okay, so let's do this. If we have 3x plus 4 squared, that means we are taking that binomial times itself. So we're going to use the FOIL method to get the answer. So that gives us 9x squared plus 12x plus 12x plus 16. 12x, that gives us 24x. And plus 16, that would be our answer. Now, if you don't like the FOIL method, you can actually set this up as a box method to multiply out. Okay, so you have this box method set up, right? So you have 3x, that's 9x squared, 12x there, and then 16 there, and you just add the two mirror terms to get the 24x. Next example. Here we're doing the same thing. We're taking 2x minus 5y and then time itself. That's what it means to be square. Okay, and then we apply the FOIL method, so that gives us 4x squared minus 10xy minus 10xy, and then plus 25y squared. This is negative 20xy plus 25y squared, right? So we're just gonna FOIL, right? And this should be our answer. Here we have a binomial times itself with opposite sign in the middle. Okay, I want you to pay attention to that. Okay, so let's see what's gonna happen. 25y squared minus 15yz plus 15yz, and then minus 9z squared. Okay, all right, so that will give us 25y squared, positive this, negative that's going to cancel out, so we're just left with 25y squared and minus 9z squared. Okay. So it seems like the middle terms cancel out if we take a binomial times itself with the opposite sign in the middle. We just kind of square the first term and then subtract the square of the second term, and that's what we got there. Okay. So using that right there, what we can do is we can kind of guess what this turned out to be, because you have a binomial times itself with the opposite sign. So if we get this right, we know the middle term is going to cancel based on this example. Okay. What we can do is we can say, okay, well, that's just going to be, let's try the 4a squared and then the 7b squared. Let's try to see that work. 16a squared minus 49b to the 4th. So we're guessing that that's our answer. Let's check it. Let's check if our answer is correct. If we were to do the long way and then FOIL it out, okay. Let's see, you have 4a minus 7b squared, 4a plus 7b squared, times, so we get 16a squared, times, so we get 28ab squared, minus 28ab squared, minus 49b to the 4th, right? So middle terms cancel out again, so we have an answer as 16a squared minus 49b to the 4th. So we were right. So if we multiply two binomials with the two same binomial with just the opposite sign in the middle, we just end up with just the square the first term minus square the second term. Okay, so let's apply that to the next example. Same thing here, same binomial, just opposite sign in the middle. So I'm gonna get, okay, we square the first term is gonna be 36 squared. If we square the last term, is gonna be 116, and then we're just gonna be difference of that. Okay, so make a note of this because in the next couple lessons, we're gonna go backwards to factor this type of binomial. Okay, so the step going backwards is called factoring. All right. Last example, we're gonna get what, x to the fourth, and then square of what is y to the n squared. That's just become y to the 2 times n using exponent property. Okay. So what we can make a note at the end of this is that if we have a binomial times another binomial where it's almost the same thing but different by the sign in the middle, this is going to equal to the square of the first term minus the square of the second term, and there's a name for this. We call this is called the difference of square formula. Okay.